You want muscle protein synthesis to be greater than breakdown as long as you can. Now, that's never going to happen forever because no one dies at 100 years old looking like Mr. Universe, right?
We are back for another episode of Sup Beast. As always, Zane Spruce, Neal Spruce, and today we're going to be talking about protein, like everything protein, how it works in all the systems and the stages of life and how to build muscle, etc. Okay, so this is going to be a deep dive on protein. If you want just like a short Cliff Note version of that in our macro section, it's probably all you really need. But this is like protein is such a large topic these days and like a hot topic to where, you know, if you want to learn more about it, this can be your one-stop shop video for everything you need on protein. So it's going to get pretty in-depth. You'll try to simplify it for us because I'm not so well-versed in everything, but we got our sheet here of what we're going to go down and talk about, and we'll get started. So let's just briefly describe the role and function of protein in the body.
Well, it actually has two functions, even though people think of the primary one of, muscles and all your proteins. You have thousands of proteins in the body, and they're all made up of like the 20 basic amino acids. And they're all designed so that they're triggered when you need some protein being made, like your gut. I mean, the cells of your gut, the lining of your gut needs protein every 3 days. It's turning over millions of cells. Right, your muscle tissue is turning over, pretty much 2% every day. So it needs protein to be able to do that. Without the amino acids, it can't do that. You just keep shrinking until you're gone. So that's the number one purpose for it is rebuilding all your tissues because that's what we're made of. We're made of amino acids. Our skin's a unique protein. Our hair is unique protein. Our hormones we produce are unique proteins. They're all just different chains of amino acids that comes from our protein. So that's that one. However, because your body relies on energy, you're dead without energy. Protein is just that unique macronutrient that can be used also for energy. It's preferably not being used, otherwise we want to keep our structure strong and everything else, but when you don't get enough calories in, it's going to take it and convert protein to energy. So it has both those abilities. Now again, they have a million functions in the body because they're all different proteins. They do signaling. They're part of the neurotransmitter system. So all our proteins that we ingest are now completely rearranged to where we actually need to put them. And that's, of course, the makings of the different proteins in the body, and then the ability to use them for energy. They're what we call all the amino acids are glucogenic and ketogenic. They can be burnt as a glucose and fill our liver back with some glucose, or what we call gluconeogenesis, or they could be ketogenic. There's only a couple of them that are ketogenic, and then they get burnt like a fatty acid, like keto. It turns into a ketone, and it's burned that way. So it goes both ways, and that's the importance of protein. Obviously, you can't live without it.
That's how it's broken down. It can go into the glucose or into the ketone.
Okay, put it this way. If you don't take in enough energy, okay, in other words, let's say your body burning 3,000 calories a day, and you take in 2,000. Okay, so it's got to find 1,000 somewhere else, right? Because energy cannot be created. Okay, so it's got to find it in your body. It gets it, and it breaks it down. And about half of that, or a little less than half of that probably, depending on how much protein you're taking in. Just say you're taking in the basic amount of protein. Let's say you're taking like 100 grams a day, and you're a 200-pounder. Well, if you're only taking 100 grams a day, there's going to be a significant amount of your muscle being broken down for energy. Because 100 grams isn't even barely going to feed your muscles if you were eating enough energy, taking all 3,000, but now you're down to 2,000 calories a day. It's got to find 1,000 calories, and it's going to go right to your muscle and start to break it down because it's already breaking. Muscle goes through a normal cycle. It's breaking down, and building and breaking down, and so now it's going to just go accelerate the breakdown and then convert them to energy so that your body stays alive because the beating of your heart and the functioning of your liver and your formation of blood cells and all things are far more important than how big your bicep is. So your body's going to prioritize energy over your muscle. So that's energy. So protein goes both ways. And that's a big deal because that really makes it very scientific about how you want to target the protein intake and where you want it to go in the body. We'll get to all that.
And so how is protein broken down?
Oh, just you eat when you eat protein, we call it intact protein. So you eat beef. We call that intact protein. It's got all 20 of the amino acids, right?
Yeah.
The proteogenic amino acids. And if you eat fish, same thing. It's what we call intact protein. You take a protein powder that has all 20 of the aminos in there, okay? That's intact protein. In other words, you've got regular protein, all the amino acids that you need there in the right formation. Now you go and you ingest it, you got to break it all apart. You break it all apart in the stomach first, because that's acid. Your stomach's like 1, the pH in your stomach's like 1. In fact, if you pulled out your stomach acid and you put it on your skin, like here, like this, it would burn a hole in your skin. Yeah. But that's what so it tears apart all those, they start to break them down into peptides. So you've got a few all those amino acids that were all connected are now broken down in 2 or 3 or 4 or 5 or 6 chains of amino acids. And some are actually broken down all the way. Now it goes into your duodenum, which is the upper part of your intestine, and the jejunum, and they're starting to float down in here. And now the body's breaking it down even further and beginning to bring it into your systemic circulation. So remember, scientists call your gut really sort of outside the body, even though it's inside your body. It's still not, the nutrients haven't got in there yet. Once the nutrients go into and they're absorbed in your small intestines, they go now into your systemic circulation. Now they can be absorbed into the tissues they need to be. So that's how we break down protein. We break down single aminos, and now most of these amino acids are going to go to the liver, and the liver is like the hard drive of your body. It's like the brain. Yeah. Okay, it decides where those aminos are going to go based on your needs. Oh crap, we got to break these down and just use them for energy. We'll just keep it here. Okay, that's called splanchnic extraction of the amino acids. Now, it's also going to say, oh no, we got to go there. We got to get it out there to some muscle tissue over there. Just keep these muscles, because they're doing a lot of work these days. We got to keep enough there, but we're going to keep some of it here for energy. Yeah. Oh, then we're going to send some over here. Oh, neurotransmitters got to be made. Okay. Well, heart and liver muscle and liver tissue's got to be rebuilt. Everything else. So we're going to break it down and use it for this and make a different protein. Your skin replaces itself every 3 or 4 days. You start to lose so many. When I say that, I mean you're losing skin cells. Constantly. And there we got to replace themselves. And that's all, of course, from the protein. So we break it down, and then the body decides to put it together in whatever chain it needs. Of the thousands of different proteins the body needs, it decides where it needs to go. The average person just thinks of protein as skeletal muscle proteins, okay, which is just one of the thousands of different types of proteins in the body.
All right. And what is the impact of protein on hormones?
Well, it's more what is the hormone impact on proteins, if you will. What I mean by that is that if you have, for instance, a sedentary prepubescent child or in puberty child, their hormones are up because they're growing naturally. They don't need as much protein per pound as like a really old person who has very low testosterone, very low anabolic hormone levels, because they need to overcome that resistance, and that's part of it. Their hormone levels are suppressed because, again, that happens, after puberty pretty much. It starts going the other way, and then it really goes the other way in your 30s and your 40s and your 50s. So now you need more protein. So hormones can make protein work better because they also suppress muscle protein breakdown. The higher your hormone levels, your testosterone or your IGF-1, insulin growth factor, and all these things, you actually don't break down as much. It won't be as deep a dive. You have to break down protein, because if you don't break down protein, then you can't reform the muscle to be bigger. So it's always in a constant state of flux. Muscle proteins are in a constant state of flux, breakdown, synthesis, breakdown. Now, when you add a physiological stress to that, it can go, oh, I got to build more muscle to handle this, okay? So that's why it's got to be in a constant flow. Otherwise, your muscles would just be the same size no matter what you did. So that's kind of what's going on. And hormones just give a little less breakdown, and they would allow you to build a little bit more muscle if you had a higher amount of hormones like you do when you're growing. But when you stop growing, then things pretty much plateau.
All right,
and that's how hormones affect it.
Okay, so I'll restructure that question just a little bit and see if that makes any sort of difference in your response. So if you are not taking in a sufficient amount of protein, will that impact your hormones? Or if you're getting adequate, will that impact
now, if you're not getting enough protein, would it impact?
And I'm not saying like you're not eating any, right? Like you're just not, maybe you're not hitting your RDA or whatever it probably is.
If it does, it'd be transient.
Yeah.
In other words, for instance, leucine and protein by itself triggers insulin. Insulin is really the most anabolic hormone in the body. People don't realize that. Without insulin, obviously, we're dead. So you have to have insulin all there to drive, your sugar into your cells and maintain that level. But it also is the most powerful anabolic hormone. Nothing really happens without it. Even the triggering of building muscle and so forth. Yeah. You've got to have a little bit of insulin in the body to make things always work. So yes, if you're not getting enough, then you're not getting enough protein. Your insulin levels aren't going to be where you would like them to be to build muscle. Now, again, we don't want insulin going crazy throughout the body in the average, older person or regular person or anything else. So you don't need to really look for that. But whatever effect your protein intake has on your hormones, whether your anabolic hormones, your catabolic hormones like cortisol, it'd be transient. Okay. As soon as you bring it up, everything's going to kind of normalize.
And then you kind of touched on this before. So how does protein contribute to energy production?
Yeah, well, because protein basically, it's got a carbon skeleton like anything else, but it's got a nitrogen radical. That separates it really from the, obviously the entire structure from a carbohydrate. So what we do is just kick off the nitrogen, and then we use alanine and glutamate to take it away. Okay, and then we end up, it goes into a little cycle and we get rid of it. And then we can burn the carbon skeleton just like a carbohydrate. And it can enter the Krebs cycle or the TCA cycle, whatever you want to call it, enter it like basically as a sugar. Okay, and go in there like a glucose molecule, or it can enter or it can be turned into a ketone, and we can burn that for energy. So again, that's how it supplies energy for us. And the only time it's going to need to do that, not the only time, but is when when you're not eating every 4 hours, which we'll get to, which is kind of the old 4-hour rule that every athlete in the world learned when they were very young. Okay, we'll talk about what really established that. That's an important thing we want to make sure we cover. Okay. Called the post-absorptive time.
Yeah, we're just laying a foundation right now for everything we're getting into. So let's move to what is muscle protein synthesis?
Well, that is muscle protein synthesis, exactly what it says. We're now building muscle proteins, okay? The body is constantly going through a wave. Muscle protein breakdown, okay, is fairly...
You can group these together if you need, because that's going to be right. That's going to be right after this.
Yeah, so. Muscle protein breakdown is fairly constant, so everybody should know that. It's constantly working, constantly breaking down. Then it can never go. You can never favor muscle protein synthesis until food comes in. Otherwise, you're going to keep breaking it down and breaking it down and breaking it down. Now, when you break down your muscles, skeletal muscle breakdown, when you break it down, your body will just recycle the amino acids, but you're going to lose a bunch of them.
Yeah.
Okay, you're going to lose the ones that were converted to energy, and you're going to lose the ones that like your gut needed to rebuild its tissues, or your heart needed to rebuild its tissues, or your liver needed to rebuild its tissue, your skin. So you're going to lose those aminos. So what happens is that existing structure, even though your muscle will go through a muscle protein synthesis cycle while it's going through the breakdown is going to be greater until muscles, you take in more amino acids to be able to feed the muscle, because the muscle is secondary to all those other needs. Those are needs that keep you alive daily. So if you think of the skeletal muscle of just a giant reservoir of amino acids that it can call on anytime it needs it and use it in almost any function it needs to in the body to replace the tissues to keep you alive or to give you energy to keep you moving, all right? But what we want to do is satisfy the energy requirements with diet, okay, and then have enough protein to be able to keep skeletal muscle protein synthesis even if you're not working out, even with breakdown. And that's the way it is for all adults until about the 3rd decade of life, maybe the 4th decade of life. If you don't work out at all, your muscle protein synthesis is even to your breakdown over a 24-hour period. It's even. That's why you don't change.
Yeah.
I mean, otherwise you'd be just changing all the time. And again, that's if you're eating, you're a normal, healthy adult and you're eating your maintenance. Your muscle protein breakdown is even. Now remember, I said you have to break down muscle. If you don't, it can't change. Muscle tissue, skeletal muscle is extremely, scientists like to call it plastic. You can mold it any way you want to. Yeah. Adding stress, or we can take it apart because we need energy. They add stress, and they'll try to find more amino acids to be deposited in the in those tissues. So muscle protein synthesis is going on every single 4 hours. And this is, I think we probably should talk about this right now. Mm-hmm. And that's the post-absorptive time frame, the post-absorptive phase. So it takes from a mixed meal. If you had today, you just had a fish dinner with rice and vegetables and everything, or you had a steak, a lean steak. I'm always saying lean because if it's high in fat, then it's going to clog up your stomach and take even longer. But you got that, you got grains, you got your all your a real balanced mixed meal. It takes about 4 hours for your gut. Remember, I went through the whole thing in your gut, your digestive system here, break everything down, stretch it, and then push it through in the intestines. All the enterocytes be able to pick up all these nutrients, and it goes into your systemic circulation, kind of go into the portal vein and kind of go into the liver. Now you're digested, and now all those nutrients you extracted from your food you just ate 4 hours ago, they're now distributed in the proper areas of the tissue, depending on your body's physiological need. Was energy more important? Then we're going to take some of those aminos and use them for energy. Or, if we didn't get enough from carbs and everything else. Okay, so that's the post-absorptive response. Now, I just said that was 4 hours, right?
Yeah.
That 4 hour timeline, and again, give or take whatever it is, depending on the foods you ate and everything else, that 4 hour timeline, from that moment on, you are catabolic until your next feeding. In other words, so you have now stored it in your tissues, and your body's going like this. And this is an important thing for everybody to kind of get.
So is it once it gets stored, you have 4 hours?
No.
Once you ingest
Once you ingest it, it's going to take 4 hours before they are distributed to where they're supposed to be in the body.
Oh, okay.
From that moment on, if you're not eating, the body goes, okay, that's it. We're all there. Now, and that includes your fat stores. Humans are what we call periodic eaters.
Right.
So they just say an incredible, elaborate design to store food and use it later. So it takes 4 hours to break it down. Now it's everywhere it needs to be. In your fatty, some in your fat, some in your liver for glycogen, and then some in your muscles, and all the things that it's doing, and it's working. Now, that moment, ready? That moment right there, that 4 hour period, right in there, give or take and whatever, you're now catabolic. And you are catabolic until your next feeding. So muscle protein synthesis, now muscle protein breakdown takes over. Okay, and now it's just accelerate because you're what we call in a fasted state. That's the fasted state. The post-absorptive phase is now a fasted state. So you will now be catabolic all the way into your next feeding. Next feeding, boom, you make up all that. So you have these losses of muscle during that period, but you make it up as soon as your food comes in again. And you can, and again, you don't have to eat every 4 hours. Athletes do because they want to make sure that they get the biggest bang for the buck on those rhythms, the natural rhythms of the body. Muscle protein synthesis is always undulating.
Right, you're trying to min-max everything.
Yeah, that's all you're trying to do.
You're just trying to optimize.
And you're going to make, listen, you can skip a couple meals and you're going to make it all up, especially a normal person.
Yeah.
You could eat one time a day and make it all up if you don't work out.
But these athletes, they have to take that slight advantage if it provides one.
Exactly, because it will over time. Over time, those feedings there in your post-absorptive state, when you are now in a fasted state, that 4 hour feeding is going to be very important, especially protein at that particular window, because that sets you back in muscle protein synthesis, overcoming muscle protein breakdown.
This is something I've been now exposed to. So exercise though can trigger muscle protein synthesis.
Oh, it does. That's what it does. Very much, and it can actually.
So it's not just protein. Protein doesn't just trigger it, but
and that's a good point. They both trigger muscle protein synthesis together and independently. So as I just mentioned, if you don't work out, when you eat, you trigger muscle protein synthesis and it overcomes the muscle protein breakdown. So you're right back where you left off, right? When you exercise, and most people will exercise close to a fasting state because they ate like 2 or 3 hours before that, let's just say, okay? Now you'll just accelerate the breakdown a little bit. But it's triggering muscle protein synthesis right off the bat because what it does, it sensitizes the muscle. That overload of the muscle sensitizes the muscle to amino acids. So now it's going to, and that can your muscle proteins can stay sensitized to amino acids for like 24 or 48 hours. So as long as you get enough protein, it's more about the amount of protein you get, especially if you're a novice, to be able to satisfy whatever workload you did. But you're better off with taking
those. And so just to clarify, so muscle protein breakdown, that's not in reference to really exercise, right? Like where you're that's where people
normal.
Say you break down your muscle to rebuild it stronger.
Yeah, right. Well, that's commonly said because at the end of the day, you are getting what we call micro tears.
Yeah.
I mean, all you got to do is you look it up. You'll see all kinds of stained images.
So that is actual breakdown of your muscle.
Yeah. You're looking at what it does. exercise exacerbates normal muscle protein breakdown.
Yeah.
It exacerbates it. Because first of all, you're pretty much in a fasted state, okay? And you're already going to be breaking down until food comes in.
Yeah.
But you can suppress that breakdown by eating before your workout. Like when I say before, not like a food because it takes too long to break it down, but like a protein shake or a carb shake. A carbs alone, you know why? Because if you bring in carbs and you're drinking them before your workout and right there, and protein too, let's just say a little bit, already pre-digested so it gets in your system quick, it keeps you from having to have you break down your amino acids for energy. So in other words, it keeps you from breaking, better said, if you eat right before, a little bit before a workout, you know, or maybe even during your workout, you can have some carbs like endurance athletes do, you will suppress the amount of breakdown that exercise is causing. Okay. You would suppress it because you're now supplying your bodies the energy needs that those aminos when you break them down. Because when you work out, your muscles, you're using branched chain amino acids as an energy source a little bit, depending on what your nutrient level is in your body of all that kind of stuff. But it's always going to be using some amino acids for energy and for rebuilding other tissues. So if you can supply it right before a workout or during a workout, you have the ability to sort of suppress the amount of breakdown that is exacerbated with exercise. So yes, the misnomer is exercise. Well, here the truth of the matter is exercise exacerbates muscle protein breakdown. It adds to it. And there's a little micro tears and so forth. But it stimulates muscle protein synthesis much more.
Micro tears are in respect to
the fibers.
If you work out hard enough.
Yeah, overload. Yeah,
overload.
For sure.
Like unaccustomed and whatnot.
Correct.
You can probably stimulate muscle protein synthesis without going to that extent.
You can stimulate, but that's going to stop after a while. You got to overload it more.
Yeah.
Your body becomes resistant to exercise. That's why experienced exercisers has less gains than novices.
Right.
I can take a novice and put muscle on them like a pound a week for a few months. Right?
Yeah.
You get a pound a month on an experienced exerciser. Yeah. That'd be a miracle.
Yeah.
You know what I mean? Of solid muscle. So again, it's because your body, you have to keep overloading, and you will. A soreness you get, those are micro tears. And we also measure the damage with what we call CK, creatine kinase. Because your muscles, the membranes of the muscles begin to split open from an exercise, and creatine kinase leaks out. And so we can measure that damage, and we can see how that affects, how we can kind of mitigate that. Okay. But yes, so eating around exercise is really important to minimize and suppress the amount of breakdown. That's what you really want to do. Now, again, if you don't eat after your workout, your breakdown is always going to be greater than synthesis.
Yeah.
And because imagine this. This is a good point here. So you're working out, and obviously you're already, let's say, 2 hours since you've eaten, so you're already getting close to that fasted state. You're working out, you're exacerbating it because you have to. You got to challenge the fibers and everything else, little micro tears. But breakdown is now muscle protein turnover is what we call negative now, and it's going to stay negative until amino acids come in. But can you fix those micro tears without eating? Yes, you can. Because all the muscle does, it turns itself over. And it uses its own aminos to fix it. So you could go work out again, even if you didn't eat. But you'd be weaker, and you'd be smaller, because some of those aminos, when it turns over its own aminos normally, because it turns over them all, that recycles about 3/4 of them. It recycles them, but you lose about 1/4. That's because they're being converted to energy or they're being used for other tissues.
Yeah.
So that's why you want to make sure that you get them right on a regular basis, because that's it. So that's why I always tell people, hey, listen, all exercise does is exacerbate muscle protein breakdown, and it's never going to be positive again until you eat. And just try it yourself. Work out, don't eat. Go work out again, don't eat. Go work out again, don't eat. Are you going to be bigger and stronger?
Yeah.
So muscle protein synthesis is stimulated by exercise needs the other component.
Yeah. Lately, we just had a bunch of warriors in the comments saying that the micro tears thing's been debunked. But regardless if that's debunked or not, go and do that and see what happens.
Yeah. So I mean, it's sort of it's semantics.
Yeah.
I mean, how do you want to determine when listen, when you work out, your muscle breakdown is definitely more. You can find that from any study.
Right.
I don't care where you are. I mean, but muscle protein synthesis is far and away greater stimulated than any muscle breakdown from an exercise.
Yeah.
But the bottom line is you're never going to be in a positive net protein balance, skeletal muscle balance if you don't eat.
Yeah.
So that's what I mean. So all it's doing is making you smaller, smaller, smaller until food comes in.
Right.
Because it's going to turn over its own aminos.
And since you just ended on aminos, let's talk about that in a nutshell. What are amino acids?
Yeah.
And we'll get into.
They're the building blocks of of every part of our body. They're building blocks of our skin. They're building blocks of our hair, building blocks of our joints, building blocks of, the collagen is 30% of the protein in our body is collagen. And that's a different amino acid structure than skeletal muscle. It's missing tryptophan. It's got a couple, but it's got high in some other things like, So, but again, so every protein is just a little bit different. And the amino acids are the building blocks of everything in our body, but they also act as signals in our body. Tell us when to do this, tell us when to eat, all of these things. So amino acids they have a lot of roles in the body, but main thing we're talking about are building blocks for skeletal muscle.
And they're the building blocks of protein, right?
Yeah, exactly. Because that's what we are. Protein.
Yeah.
It's protein. Yeah.
That's my one.
That's right.
That's my one little fact. I know.
There you go.
All right. All right. And so let's get into the amino acids here. There's what I've gathered is there's essential amino acids, conditionally essential, and non-essential.
Correct.
So what are essential amino acids?
Essential amino acids describe just like any essential nutrient. Such as, let's say, vitamin A or some of your B vitamins. These are essential, which means the body can't make them. You have to supply them exogenously, whether it be through diet or supplementation, same thing. So, exogenously. Has to come from the outside, exogenous supply.
That's what you said.
Yeah, I said that, okay. Right. Yeah, so anyway, so that's what you have to do. And that nutrient has to come from our environment. And then we can use it in the body because our body can't make it. So that's what an essential. So essential amino acids like the branched chain, isoleucine, leucine, valine. You've got, I think, methionine. Got to get them all. Lysine,
histidine,
lysine,
histidine.
Yeah. Tryptophan. Yeah. So these are what we call essential amino acids. And I think remember the old acronym Private Tim Hall. That's how you would kind of remember it. Because arginine is a conditional, but you would put the A in there for that. So that's how we used to describe it. But anyway, so those are your essentials. Those are the ones you have to supply in the diet, with leucine being king. Because leucine by itself, that one single amino acid by itself has the most important role in protein synthesis and turning on the muscle building machinery. Yeah. That's the first soldier into what we call mTOR, mammalian target of rapamycin, which is the sensor in all our muscle cells that tells it what to do. Build, shrink, and tells it what to do. And leucine is the trigger that says build, right off the bat. So leucine is the main one. And then isoleucine, valine. And then there's 7 other besides leucine that are involved in triggering the machinery of muscle building. And that we're using that now. There are all kinds of great experiments around. We use that in the athletic population as well, because it tends to bypass splanchnic extraction and go right to the muscle and tell it to turn on the machinery, even when you're working out and you're trying to break it down. So there's some pretty cool stuff going on without essential amino acids count. So that's what the amino acids, that's what they're involved with. And so those are the essentials we just talked about.
Yeah.
Gotta have them.
I hear a lot of things about tryptophan. What is...
Well, tryptophan is an essential amino acid, so it's in all of our proteins. It's in our muscles and so forth. But tryptophan is also, the reason you hear about it, because it was actually a supplement that you could buy separately in free form that would help with calming people down. It actually promotes like dopamine or serotonin in the body, so it can actually make you feel better and relax or sleep. It was a sleep thing. And then there was a big raw material problem back in the 80s, and they pulled it as a supplement off the market. You can still get it. All it was just a bad raw material supplier that did that, and people got sick on it. But anyway, bottom line is tryptophan's an important essential amino acid for sure.
Right.
Yeah.
What makes amino acids conditionally essential?
Stress. So think of it that way. If you're stressed, whether you're sick, really sick, you're going to need a hell of a lot more glutamine. Okay. Cardiovascular problem, you're going to need a hell of a lot more arginine. Or you might have some genetic issues where you just really can't produce those amino acids very well, because they can be produced from the essentials, but not fast enough during stress. For instance, take glutamine is a classic one. I think alanine is another one.
I have a list here.
Yeah, go ahead. Read
There's arginine, cysteine, glutamine, glycine, proline, and tyrosine.
Yeah, okay. Those are conditionally. So glutamine is the real big one. Because glutamine is robbed first for the rest of the body. Your muscle actually, 90% of the glutamine in the body is actually made in the muscle. And and all the extra will go to a little pool. So when your body's stressed, it can draw off the pool because that glutamine feeds your intestines. Remember I said your intestinal cells, your billions of intestinal cells, they replace themselves every 3 days? Well, glutamine is actually the energy source for them. So it goes down, that carbon skeleton is used there, they can now replace themselves. So and then when your immune system is on your gut, 70% of your immune system resides in the gut there, in there as well. And guess what? Your immune cells use a shitload of glutamine. When you're sick, bang, they get fired up. So now your intestines is robbing the glutamine from your muscle pools, and now your muscles got to make it and just take it straight down into the immune center there and give yourself glutamine. So that's definitely you would need help during stresses, and that's how we give that to athletes that are dieting. Like yourself, when you guys diet for fights, they have to make a certain weight. Man, you're mainlining glutamine because you're under stress from caloric restriction and diet restriction. So it's going to rob your glutamine pool. When people get in accidents, car accidents, and they're wiped out or they're burned, they'll put them on IV of glutamine in a hospital. And it comes right in. IV obviously bypasses the oral take and go right into the system and can kind of fill the pools because you can't make it fast enough in your body.
Yeah.
And glutamine is used for everything. Heat shock proteins, everything that protects us during times of fast cell growth. Glutamine is never made at the right amount. So that's what a conditionally essential amino acid is. And when your body's under stress, you can't make it fast enough. So you definitely want to have all the aminos.
And then we got the non-essentials, which I can name them off here for you. Alanine, asparagine, aspartate, and glutamate, serine.
Yeah. So again, these are just, your body can make them at the right pace. But I'll tell you what we do know. We do know if you just tried to eat only essential amino acids, you're going to fall short on the other ones. Because the other ones also have specific places in the body to go, regardless of building a muscle protein. So they're triggers for other things. So you definitely want a good balance. So that's why we always say, and this is the take home on that whole thing, you definitely want to get 1 gram per pound of lean body mass of protein daily. And that will satisfy all your non-essential and your essential amino acids that you need, as long as you're not being calorically restricted severely. Then you're going to have more. Yeah. And you'll be able to satisfy all of those needs with if you just try to do it with essential amino acids, I've heard of people trying to do that, you're going to shortchange the amount of growth that you could have in muscles because you can't make all the non-essentials that fast, during a time when your body's being challenged to be able to use more.
So how does your body make them off of the essential?
It just converts it. It just converts another one. You got an enzyme that will convert leucine into one of the other amino acids. Okay. That's all it does. It just converts it. And there's other body parts that can just take it and take one amino structure and change it to another one if it's needed to finish it.
Because our body can do that, and that's why they're not essential, right?
Yeah. These are definitely.
Since you said essential is our body can't do it, non-essential is our body can do it.
Our body can do it if it's from the starting materials.
From the starting materials.
Exactly.
Which is the essential.
Right. Yes, okay. Correct.
Got it. So now that's kind of like the whole foundation there, what is the importance of bioavailability in protein?
Yeah.
If there is, if you're
there is. Oh, absolutely. And I think there's what do we call I always forget this.
I remember
the protein protein digestibility corrective amino acid score.
Yeah, PDCAA. I think it was.
Like that. Whew, I don't know how you can pull these things out. So bottom line is, it's one thing to have a great amino acid, have all the amino acids, but if it takes a long time to digest them, you're just not going to get the same value. So like whey protein got the highest biological value, the highest scoring, all that of any, because you do want it, you want to be able to get it in before you lose it. Plant proteins, the problem with them, they're bound up. They'll hang in the gut, and you might lose a lot of the amino acids before your body can absorb a significant number of them, because they bind it up, and they don't have the high amount of leucine, or they don't have the high amount of the branch chain, or even the essential amino acids. Very low. Soy is the only one that might have a good score, but it's still not as digestible as like a whey or an animal protein. Animal proteins are always the most bioavailable, pretty much. You can make a plant protein better, breaking it up, putting it in peptides. There's ways of making it easier, and then you can fortify it with other amino acids to make it as good. But that's all bioavailability is that. And again, the bioavailability of a food, you got to break it all down. It takes all that long, like 3 or 4 hours, like I just mentioned. Now, the bioavailability is going to be greater in a protein powder because you've already done that. In a laboratory, we already broke it down. Now you're just taking it in a powder form, and easily it's much more bioavailable than it will be from food. And then same thing with free-form amino acids. And free-form is the most bioavailable. Yeah. As soon as it goes in, it's going right into your body, pretty much, amino acids.
We always recommend, right, the 1 gram per pound of lean body mass for protein. Yep. Is there an official equation that is like for that, or is that
no? That's it. I mean, that's what you look at any top protein scientist. So you can't look at the RDA. The RDA is comical.
We'll get to.
I know. I'm just saying it's comical, but we've learned so much about protein over the last 30 or 40 years. That's why you see commercials on TV. Every other commercial is a frickin' Ensure, it's fortified with protein. You get all this amino acids. I mean, all this kind of stuff. Everything's about protein because we've learned so much more. The older you get, the more you need. And even if you're younger and you're exercising, you need double or triple the RDAs. So we've learned a ton about it. But that's the right number. That works for anybody.
All right.
That number works for anybody. Unless you're dieting, and it's going to go above that.
Then you can do more.
Then you can go 1 gram per pound, and you can even go more, 1.5 grams per pound.
Dieting when you're leaner, right? Not.
Yeah. Dieting when you're leaner.
Yeah.
Yeah.
Because when you're dieting and you're overweight, you probably
you'll be fine at 1 gram per pound of lean body mass for sure. Yes.
Just to clarify.
Depending on how big the deficit. If you're in a massive deficit, I'll put it this way: obese people are put on protein only diets.
Yeah.
That's all they get in a liquid form. So it's digested and everything. You have to be monitored by a doctor when you do that.
Yeah.
But they're in a huge deficit. So basically, the only calories they're getting are protein. No point in having anything else. Yeah, it's pretty brutal.
Dang.
But they'll drop their weight quick because that can save their life if they can get 100 pounds off quick. Those are those liquid diets. I'm not a fan of them, but for people that are morbidly obese, that might be the way to go. Certainly before you go into bariatric surgery or anything.
Yeah, that's like a lifeline intervention.
Yeah.
Though.
Yeah, totally.
What is the RDA for protein intake?
It's a joke. It's comical. And it's stubborn. It just hasn't moved because no one pays attention to it anymore. No one does. I mean, not a single protein scientist. But the RDA just left over, just hangs around, is 0.8 grams per kilogram of body weight, which would be about 0.36 grams per pound of body weight. And by the way, remember, I want to remind everybody what RDA stands for, recommended dietary allowances, but stay with me here. What it means is RDA is not meant to be optimal or final. It just happens to be, it would help, it's designed to prevent a deficiency. So what they're saying there, that a human being that was sedentary, young enough till they had strong enough hormones, so it can't be an older person, even though they never changed it for older people. You're getting all the right recommendations now, but they never changed. It's just stubbornly stuck there because no one pays attention in the public sector anymore. So if you are all of these things here will increase the need for protein. But if you were sedentary and you were young, so in other words, you didn't do anything, you weren't active or anything else, you would be in what we call protein balance. You would be in nitrogen balance. You wouldn't have nitrogen loss. If you have nitrogen losses greater than your intake, that's how we measure it. That just means you're losing protein somewhere in your body. But what they did is they would just give people just enough to where they didn't lose the identical amount of protein going into the body and the identical amount of protein going out of the body. So it was a nitrogen balance. That's all. So the bottom line with that was it doesn't make any sense anymore. It just did back then. So that would prevent a deficiency in a sedentary, very young person with good high hormone levels. Mm-hmm. Because, give an example, a 14-year-old kid can take 10 grams of protein. I would need 40 grams of protein to do the exact same thing in my body at my age. It's 72. Think about that for a minute. That's how good hormones, how much they help utilize protein that much better. Mm-hmm. So that's how it's all based on that. So obviously it's just a joke. No one pays attention.
All right. And then you said nitrogen balance?
Yeah. That's the same thing as protein balance.
Protein balance,
yeah, same
which
thing.
Is?
Net protein balance.
Okay.
In other words, your net protein balance is even. If in a 24-hour period, you lost just as much as you gained.
Okay.
And everything's even.
Got it. All right. And so
we want to be in a positive protein balance if you're putting on muscle.
Right.
You retain more than you lost. Got it?
Yeah. So how does that... Because why is it disputed, I guess, a little bit to not, like, what is the recommendation against doing 1 gram per pound of lean body mass?
There isn't any anymore. There hasn't been in years. Now, back in the day, people, and this all the way back to the 80s, even all the way up to about the 80s, even some early 90s. I remember some dietitians, some whacked out dietitians that were just like really old fashioned. Oh, you're going to kill their kidneys. That's too much protein. Because, you got to, it's about the nitrogen, that's a little hard in the kidneys sometimes, what people would say. But of course, we knew that was just, didn't make any sense. So and they also said there was also bone mineral loss. Because what happens is that when you eat a lot of protein, it becomes acidic. And your body has to balance your pH out every day. Yeah. So it will rob calcium. They used to say it would rob calcium from the bone to make it the pH, normalize the pH in your body if you had too much protein. Well, it turned out it was actually the opposite was sort of true. No, that would happen, but you end up with weaker bones if you don't get enough protein in the first place. So it's, what's first, what's second, all that. So it turns out that those have all been debunked. The bone loss has been debunked. The kidney issues have been debunked. Up to 4 times the RDA. 4 times the RDA has been used over long periods of times with no issues on any normal, healthy person. If you have damaged kidneys, or you've got poor, and we're not talking. Listen, I'm not clinical here. I'm just saying, if you do, then you want to keep your protein at a certain level. Yeah. Okay, because your kidneys can only take so much of being able to use that. But otherwise, your kidneys will be perfectly healthy your entire life if you live to be 120. If you get the right amount, 1 gram per pound of lean body mass, you're going to be absolutely fine. But again, if you've got poor kidney health, then I wouldn't jump it up without talking to your doc.
And so that covers why is protein intake considered potentially harmful. Mm-hmm. So, and then what is the upper limit then? Is there an upper limit?
There is no upper limit. Yeah, there's none been established. I have an upper limit for it. When you start taking in too much protein and it's taking the place of other healthy foods that you need. Yeah. You need some good healthy carbs out there, your fruits, your vegetables, and even your whole grains. And if you're just eating protein and you're cutting some of those things out, you're shortchanging yourself. So that just means that you're just eating nothing but protein and then you're throwing a little salad around. Okay, so again, I think you're going to be fine at 1 to, bodybuilders towards the end, of course, it's transient. You got to remember, that's a short period of time. When your last 6 weeks, we call them death days going into a contest. You're so fucking hungry, you're going to eat your arm off, right? Yeah. So those are the times where your protein's probably could even be 2 times your body weight. But that's pretty, and hardly any carbs. You're down to like 50 grams of carbs a day at that point. You're just spacey and wiped out. So again, that's training. You only do that for a short period of time. Yeah. You couldn't live like that anyway. Yeah. So I don't think you can overeat protein anywhere.
Yeah. All right. So let's start getting into the roles protein plays in certain scenarios of weight loss, hypertrophy, and all that stuff. So we'll start with weight loss. What is the role of protein in weight loss?
It's exactly the same thing, except it's just more important. Because anytime you go into an energy deficit, you're taking in less calories than your burn, and you're doing it not too big, but let's say you're 500 calories less a day or 1,000 calories less a day, at least 20% of your weight loss is going to be proteins. It's going to be lean body mass. Well, you don't want to do that, right? We don't want to. No. Because when you gain the weight back, you're not going to gain the muscle back. You're going to gain pretty much all the fat back, only. So that's how important it is. Protein can stave that off. And we know that diets 3 times the RDA in protein it can almost wipe out that deficit of lean body mass loss.
Or you don't lose the 20%.
When you don't lose to 20%, you can knock it down to maybe 5%. Yeah. And if you add resistance training, we can actually take it out up to about a 750 calorie deficit. When you get to 1,000 calorie deficit, it's very difficult. Then you're gonna have to supplement. Like we talked about essential amino acids, we talk about your multivitamin minerals, you talk about some other things, creatine. They can help you actually build muscle when you're in a deficit, which is that's how bodybuilders can get. But even bodybuilders getting towards the end, as you get way down, the leaner you get, the more your body's going to go, oh shit, I got to do something about this guy's going to die. Because that's what your body thinks. This fucking guy's going to die. So what it does is starts eating away its tissues there to make sure that, because those things that's what use calories. Your muscles what's used the most calories there compared to body fat. So it's going to go after, I got to get rid of that. And it also shrinks your organs too, because they use a shitload of calories. So now your organs are shrinking as well because your body's got to get rid of what uses those calories when you're on an extreme low calorie deficit. So protein is so important during that time, and it's going to come up over that 1 gram. So that's its role in weight loss, is preserving lean body mass. Yeah. That's its role. preserving lean body mass. Otherwise, it's going to be distributed all the way out through your body to make up for that energy deficit you're in.
All right, and I'm sure this is going to be a big one here. So, what is protein's role in maintaining muscle, which we kind of just talked about there, and building muscle, so hypertrophy?
Yeah. Well, what weight training does, or any type of resistance training, what it does, it tells the body that the muscle is more valuable than protein, because this guy's going to fucking work every day. He's going to go lift all this crazy stuff, and so now the fibers have to rearrange. So when they break down and you add a little exercise to it, they break down just a little bit more, but it also sensitizes the muscle of those amino acids, and it's telling it, oh, when the protein comes in, now you got to go to the muscle, rather than just going broken down for energy or any of that. So it tells the body that muscle is more important because this guy's freaking overloading me every day. And so that's how that's the importance there. So now we are now directing those amino acids where to go in the body by overloading our muscles. It's telling it where to go. Now, if you're an endurance athlete, then it's the same thing. It's just you're not going to hypertrophy necessarily. You're just going to end up building more mitochondria. You're going to change, the phenotype of the muscle, basically. You're really going to have an oxygenation thing, get more red blood vessels, bringing in more oxygen, all that. So it's rebuilding, same way it is for hypertrophy, but rather than adding size, it's adding ingredients inside the muscle cell so you can breathe better, so you can actually go longer and harder endurance. So really, exercise is the trigger event for the adaptation that you want when you eat the protein.
Yeah.
Right? So I just triggered it. I just overloaded my muscles. I had a leg day, it's like Squat-tober time right now. So I just to say I did a massive leg workout. Man, they're screaming for help. Okay, so it's screaming for help. Now I've gave my body a reason to take the amino acids that I ingest to go there. If I didn't do anything that day, there's no reason for it to go anywhere. It can be used for energy. It can be used for whatever. Just a regular muscle protein turnover.
All right, and what is the muscle full effect?
Muscle full effect is something that all these great researchers that I steal all their information and try to dumb it down for everybody because they're so much smarter than I am. That's where I get it. Was something they just kind of discovered back in the early 2000s. Actually, it was in the 90s originally, but kind of perfected it later. It's how much protein can a skeletal muscle use from one sitting. In other words, that's really it. Now, it can be anywhere from 20 to, originally everybody said 20 and 25 grams. That was it back in the 70s and 80s. But finally, the smart researchers figured it out later. Well, that doesn't make any sense. The world's strongest man is 450 pounds, and then Olympic gymnast is 90. So you're going to tell me they're saying muscle full effect depending on the work size and everything. So it's size and activity in the muscle area and everything else that would really determine it. But the number is 0.2 grams per pound of body weight. Okay.
Body weight?
Yeah. 0.18. I do that by 0.2 for, you could use for like either body weight or lean body mass. Either way. If you're lean, you can just use body weight and make it easy. And so that'd be a 175 pound person. That'd be about 35 grams of protein. And that skeletal muscle will use that from a normal workout. Now, if you're doing a crazy workout, remember, there's no real anabolic ceiling to protein. Because remember, we're talking about skeletal protein. What about all your other tissues that are turning over even faster than your freaking muscle? So it's whole body protein synthesis and whole body protein balance is what you really want. So in other words, you want all your other tissues to get enough as well. So it doesn't hurt to have 40, 50, 60 grams. And you can use 60 grams throughout the whole body as it's replacing its tissues. But the most a muscle will probably use is that 0.2 grams per pound of weight. That's about the most the average one would be able to use. But I've heard things up to 60 grams and, for avid exercisers at one meeting. But you just want to spread it out. That's the whole thing. And
so, I mean, we kind of touched on this with the muscle protein synthesis and breakdown and the exercise and protein relationship. So
yes, exercise and protein relationship is that, but it deserves its own little space here. Exercise, and everybody should remember that, exercise sensitizes your skeletal muscle for amino acids.
And that's
there's a heightened nutrient sensitivity. So that's the muscle protein synthesis is now going to be really high, about 15 minutes, during exercise and then after exercise, it's going to be very high. But if nothing comes in, it's got to turn over its own tissue. So you want to get that protein in as soon as you can after an exercise. It's always most important at the end of an exercise. Not nearly as important before, after. because of all the protein breakdown that's been taking place that you accelerated there, this will suppress it. And because remember, your muscle's all sensitized to it now. So all your enzymes are fired up to replace this and build back the tissue. All right. And then what happens is if they don't find the amino acids, if all that building material doesn't show up, they just go like this, you don't need me anymore. And it goes down. And you kind of lose that little window. Now you can pick it up again a few hours later, but you may not get the same peak. So that's the idea. You really do need to, the combination of exercise and amino acids, when they converge in a pool, good things can happen because they both independently stimulate muscle protein synthesis. Now you're going to get the bang for the buck. It's one thing to have muscle protein synthesis, another thing to have enough amino acids to satisfy it.
Yeah.
Otherwise, it could be heightened, it could be there, you got to be ready to go, but you got not enough building material. So you really want them in conjunction with each other. That's why the 4-hour thing works, and always some protein right after your workout. Always. Right. And I don't mean I mean like a shake, because it's faster digested. Remember, food's going to take 4 hours to break it down. Don't forget that. And
we'll get to whey protein for hypertrophy in a second here. So what is mTOR? Because I've seen that a lot.
Yeah.
So what is that? MTORC?
Yeah. Mammalian target of rapamycin. And it is the sensing device in every muscle cell. All of our muscles in the middle, we got mTORs in there, and it decides what to do. Break down muscle protein synthesis. It's really there for muscle. It's a sensing device of all the nutrition value and all the extra physical forces that are going on that muscle cell. It's balancing all that out. There's another protein in the body besides mTOR, and that is AMP activated protein kinase. Now that measures the energy level in the muscle cell. Okay? So now if the energy level in the muscle cell is low, and yet you're doing contraction and you're trying to activate muscle to build, it's not going to allow you to do that. It's just going to allow it to break down because you don't have enough energy. Energy is more important. So those two are the sensing devices, your AMPK, AMP activated protein kinase, and then mammalian target of rapamycin. That senses all the nutrient values that are going on, and it senses the entire environment of whether you're in contraction mode or you're working out or you're not working out, you're resting, and it decides that is where growth takes place. It's right there, or growth or lack of growth, because the outside stimuli isn't the right amount to be able to make mTOR say, hey, build more muscle. So that's what it is. It just senses everything. It senses the entire environment.
What is the impact of essential amino acids on muscle protein synthesis? Okay. We already talked about like leucine kind of turns on it. Yep. What is, I guess, the role now in hypertrophy as well? And so some wonderful studies were done. I actually was fortunate enough to write a little chapter in a big text for college postgraduate students on that. And this goes back in 2003. But all these guys, all these fantastic researchers in the 90s discovered that there was only these 8 essential amino acids that were involved in turning on the muscle building machinery. And what it does, because for some evolutionary reason, these 8 amino acids have the ability to be in free form and bypass what we call the splanchnic extraction. So the liver doesn't get really a shot at it. And they go right to mTOR. They can get right to the muscle cell. And if you can keep a large outward flow, in other words, the body is already sensing it's coming from an exogenous source. It didn't turn over its own. Because don't forget, if you don't eat, it's turning over its own. There's essential amino acids floating around. But that's not. That's more intracellular. This is coming from an outward. If there's outward flow going inward into the muscle cell, and it can get to mTOR, that's the magic. Leucine and those other ones. Because leucine by itself, if you don't have the other ones, they're the limiting factor then. Then you can need valine, isoleucine, and then on top of that, there's 5 other ones now that you need to come in there. The other essentials. Yeah. There's 9, but you don't need tryptophan to do this. It's an incredible model these guys discovered because it can actually turn on the muscle building machinery without exercise. And of course, because it does that anyway, but now it can actually stave off the loss of muscle. It suppresses breakdown more than anything else because that's what it's doing. It's actually suppressing the natural flow of breakdown. Is pretty steady in the body all the time, right? What the undulations for muscle protein synthesis are what we can manipulate. Okay, so now what's happening here with this, you're now just telling mTOR, just keep building muscle, build muscle.
And again, if you don't have enough energy or whatever, or your hormone levels aren't right, it's not going to do a whole lot of good. But at least it can help. It can keep you from muscle wasting if you don't work out, and it can add more muscle with less calories, which is a big deal for like bodybuilders and so forth. So that's what the essential amino acids are. They're the only ones that turn on. Non-essentials do not turn on the muscle building machinery. They just finish the process after you've turned on the machinery to build muscle. So there you go. So you want that outward flow. Think about just because the body gets so smart. It can tell it's where it's coming from, obviously. It has to be coming from here. So, oh, God, we're getting extra help. So now we can keep the machinery building. Because if it was turning over its own, that would be intracellular. And then you would go, oh, the body goes, well, I'm not going to build any muscle. I'm just turning my own over. And of course, you're just shrinking it.
Let's talk about the timing of protein to maximize hypertrophy. Yeah. So what is that timing looking like?
Yeah, and I'm sure that everybody kind of figured that out already. 4 hours. Right. Every 4 hours is it. I mean, a mixed meal every 4 hours or whatever. But you know, listen, I still like this, and you can have our scientists argue about it. Well, I wouldn't worry about your before your workout. Well, first of all, you definitely want to have before your workout meal, or you're not going to have enough energy for a good workout. So you've got that 3 hours before, let's say, okay? And now you've got the amino acids flying in there, and it's going to suppress the amount of breakdown that's going to take place when you're in a gym for 2 hours, okay? So you've got that going on. I mean, again, this is natural breakdown things that's always taking place. So we can suppress that, and now the body muscle protein synthesis is going to be flying when you finish your workout, and now you've got a flow of amino acids coming in from that. That's why I always like a little bit of protein and carb in a shake even before your workout. First of all, you need 1 gram per pound of lean body mass daily. So why wouldn't you at least split it up so you got a little bit before a workout on a shake and a little bit after? Doesn't make everyone agrees with after. No one disagrees with that because that will suppress the amount of breakdown that just took place over, since your last meal. All right, and the workout and so forth. It'll suppress that right off the bat. But if you take on some carbs and protein before a workout, and again, if you're dieting, you might not be able to get the carbs, but you do that. Insulin is in. Now you're getting down to your AMPK, and you're telling it, hey, we're okay here. So now we can build muscle, and we don't have to take away, and we have carbohydrate and energy. We don't have to take away from our muscle for energy for everything to happen here. So you suppress the amount of breakdown is what's happening with a little bit before, and there's nothing wrong with that. Maybe it's not that much, but it's worth it because you got to split it up anyway. And then right after, you have that other pretty much the same thing. And those are the 2 places where you want to use like a supplement because it gets in your body quick. The rest of the time, just get the rest of yours from food any way you want. Now, you can do it before bed. All bodybuilders in the off season will take a big shake before bed because you're going to be catabolic for 10 hours.
Yeah, that's what was going to be one of the questions next was protein during sleep, but go for it. Yeah.
Yeah, no. Hey, listen, you had your last meal at 8 o'clock at night. Let's say it was 7 o'clock at night. You go to bed at 10 or 11. Let's say 10. Okay, you get up at 6. Okay, so how long were you in a catabolic state? Remember, you ate at 7 o'clock.
Yeah.
4 hours is what, 11?
Yeah.
Bang, you're in a catabolic state. Midnight, 1 a.m., 2 a.m., 3 a.m. Catabolic. You're just eating all this. And then when you get up, you got to break that fast immediately with protein, at least protein. So do a quick shake or just take some essential amino acids right there. And then, or just eat a full meal. But I always like to break the fast with something quick.
Yeah.
That way I got the amino acids in there. Or do that shake before you go to bed.
Yeah.
Because that will hold you. Then you got another 4 hours almost, of that. So again, if you're really trying to maximize hypertrophy, I always advise one. As long as you don't have to worry about the calories.
Before bedtime.
Right before bedtime.
Right
always
when
advise
you
one
wake
there.
up,
I do it,
right?
yeah.
Or whatever you're eating for breakfast. So obviously we recommend that, like, a big thing is, does it matter on timing as long as you hit your daily goal? Like, are we splitting hairs, or is there a significant needle movement
There's absolutely no question that the total number is far more important than the timing. No question about that. It's just stupid.
Right.
It's what I mean by this. It's sort of a dumb argument.
Right. Because you're just
no one can eat 200. Okay, let's say you're 200 pounds of lean body mass. No one can eat 200 grams of protein in one fucking sitting without getting sick. And does that really make sense when you know the undulations that take place in the side? This doesn't make sense. But I mean, it'd take months and months to measure the differences between 2 meals a day. And by the way, I've done plenty of studies where they've shown at 3 meals a day at 30-30-30 is better than 70-10-10 as far as the protein grams per meal. 30-30-30 is better than 70-10-10. Well, if that's the case, well, then obviously it's better to just spread them all out as even as possible. That's the best way to do it.
Yeah.
And no one argues that. I mean, so just evenly, but yes, I mean, the timing is important, but certainly the total amount is more important for the average person. Yeah. We're just talking about the average person that doesn't work out or anything.
We're talking about this and like, we're trying to maximize hypertrophy. So
yeah, you're going to be, imagine being in a fasting state 23 hours of the day.
Yeah.
And you're eating one meal. So you wouldn't be, because that one meal would be 4 hours. Right. So let's just say 20 hours a day. That's pretty stupid.
Yeah.
And it doesn't, and not like you'd be miserable. Number two. So the argument's dumb.
Yeah.
You got to split it up. You got to eat, you got to eat in meals because you need energy too. You need the carbohydrates to fuel the workout.
In the context of maximizing hypertrophy, knowing that, and even if it moves the needle just a little bit, then you got to take that chance of.
But you'd have to measure it, over 6 months to see. Okay, this person ate 2 meals a day and got their 200 grams. This person ate 6 meals a day, and did it before and after, and got that. Can you imagine trying to control that for 6 months in like 100 people on both sides? I mean, it'd be so impossible. So it's just logic.
Yeah.
I just think 1 + 1 = 2. So just fucking do it.
Yeah.
Split it up.
What is the exercise-induced metabolic window, or is it also referred to as the anabolic window?
Yeah, it's the same thing. That's we talked about that. Exercise sensitizes your fibers to amino acids. It's looking for them, baby. It wants them right now. They call that the anabolic window. More than amino acids, it sensitizes it for carbohydrates. Endurance athlete, it's a must. Strength athletes, it's not that big a deal. Because again, we're spreading things out. But if you don't refill your glycogen stores almost immediately after an endurance workout, runners for hours and hours or whatever, you won't even come close to refilling your glycogen stores for your next bout of exercise. Yeah. So the carbohydrate anabolic window absolutely exists in a huge number for your endurance athletes. The protein one, it's a little different. It's definitely there. There's no question that your muscles are sensitized to it. So if you put that in and you always had some protein in there, why wouldn't you? So bottom line is, that's for protein, probably the same thing. You'll probably accrue a little bit more lean body mass by feeding in that window. That should be one of your timings over time, not the next day or the day after, but hey, at least your energy levels are going to be back.
I'm getting a little whiff of uncertainty there. So is the anabolic window a myth?
No, it's not a myth, because as soon as I say carbohydrates, that's anabolic. That's anabolism. Yeah. Replacing glycogen is anabolism.
All right, we're not just talking about but your protein one.
Your protein one, it's not a myth.
It's not.
It's not a myth. I mean, there's far more, and I got proof of that.
It's probably somewhere in between, right? It's not a myth, and it's not a bona fide fact.
Oh, it's probably exaggerated.
Right.
But it exists. There's no question. And everybody write this down and go look it up. Go to PubMed, Google essential amino acid intake, when's it most valuable? Every fucking time they'll tell you right after a workout. Every time. Well, how's that possible if this thing's a myth? It's not. Your muscles are sensitized to amino acids. You get those essentials there that quick, bang. So absolutely, protein after in that little window is going to make a difference. We'll get enough studies on that.
And so to optimize that,
you hear scientists say, right, and they just like to argue.
So shit. That is referring to taking the essential amino acids after that. That's what you would say. That's best practice. To maximize that anabolic window.
Correct.
And you are creating an aminoacidemia environment.
Exactly. Aminoacidemia environment. That's what it is. Very good.
Did some research.
Yeah, you get it way
this
up
one.
there. The idea of aminoacidemia, again, the muscle full effect. I mean, there's going to be a time where you've got more amino acids. Otherwise, you could just keep eating protein and grow. You know what I mean? Yeah, that's the thing. That's the whole thing. So that's the muscle full effect. There's only so much it will do. And that includes when you stimulate muscle protein synthesis with exercise is what you do. Okay. Now, boom, when it gets up there, there's still a certain amount the amino acids will do before they shut down. And then they become refractory. Or in other words, so anabolism is now stubborn at that. The aminos aren't working the same way. They should come to that level right there. That's aminoacidemia. And the goal is to keep that. That's why you want as much as you can get in there. And that's why using essential amino acids with an intact protein. And what a great study Park et al. Did, and there's about 50, not 50, there's like good 10 or 15 of them since then. Combination of whey intact protein with essential amino acids. Okay, a full 12-gram dose of essential amino acids. Not only did it improve the amount of anabolism that took place in fractional synthesis rate of muscle tissues alone, but it also improved whole body protein synthesis significantly and minimized breakdown. Yeah, so that's a real big one. You want both. You can always. We do protein stacking. We have people take a protein shake after they've taken the essential amino acids, or before they took the essential amino acids before the workout. And now you've got both matrices coming in there, and you will maximize whatever muscle building potential you got. You maximize it by combining the two.
That was gonna be the next question, which is how do you or is it best to hit that anabolic window with essential amino acids or whey protein? But you kind of just...
Yeah, I would always... I think you want to hit that right there with the essentials and then follow it up with whey protein. And now you've got we call that protein stacking. Yeah. You've got a food matrix coming in with amino acids that takes 4 hours to digest and so forth. You've got your protein powder that only takes 30 or 40 minutes to digest, but they're still scattered. Okay, and you've got essential amino acids take no time to digest. They're already there. Now you got amino acids flying into the muscle cell, knocking on mTOR's door, growth, and then keeping it from having to break down too much. Because think about this: the higher the amount of aminos in the body from the outward, the inward flow, outward, coming from an external source. Now it's coming in and it's flowing into the muscle cell. The muscle cells don't have to break down to use aminos for other reasons in the body, because they can now use some of these things and the muscle doesn't have to break down. So you're getting an energy source from this stuff. You're getting all kinds of extra stuff coming on with this going there. So that's the whole idea of keeping that aminoacidemia as high as possible.
For muscle building or hypertrophy reasons, is there a specific type of protein that is superior, which is... I'm pointing at whey here. Is that the superior protein
for sure.
when it comes to building? Even though you could probably do it with everything, right? But if you're really to minimize and maximize things, are you looking at whey as your go-to muscle building protein?
No one disputes that. I think it is. There's been enough studies. They compare it against soys. They compare it against casein. And compare it against other complete proteins. It'll always come out a little bit better. But you're splitting hairs. You know what I mean? At that point,
splitting hairs.
Yeah, that's pretty much splitting hairs. You're always you're going to get more bang for the buck because the essential amino acid count per gram of protein is higher in whey than any other protein on the planet. So you can't argue that. But that's the idea of taking essential amino acids with it. Now you've got even higher amount of essential amino acids per gram of protein. Yeah, way higher leucine that way.
Right.
And I want to make sure I clarified this because I don't want to confuse people. The muscle cell, when you take in those essential amino acids, it's sensing a flow from outside, exogenous source coming in this way, but that's an inward push. Okay, I want to make sure when I say outward people would think coming out of the cell. Oh, okay. That's what you don't want. That's what I'm saying. It's an inward flow, but it's coming from an external source. So inward flow into the muscle cells, what's with those essential amino acids is turning on the machinery right there. It can sense the fact that it's coming from an outside source. Okay. I just might have turned that around a little bit. I want to make sure we clarify that for everybody.
No problem.
Yeah.
But does whey have a higher leucine content?
It's almost 25 grams, I think, is 3 grams of leucine, where you'd have to get about 50 grams of soy protein to get that much. And soy is a complete protein. I don't know if it's 50, but 40 grams or so. You have to get a lot. So leucine's the highest content per gram of protein is going to be whey.
All right. And then is there a leucine threshold?
It's a leucine threshold. And everybody thinks it's around 3 grams. In other words, every one of your meals, this is important for everybody, every one of your meals, protein meals, should have at least 3 grams of leucine. Okay, so that's 3 grams 6 times a day, whatever. So that would be about, 35, 40 grams of soy protein, of whey protein. You would get 3 grams. Let's say if you got 3 grams, you're probably about 25 or 30 grams of whey. So you're always going to get there. If you're eating 1 gram per pound and you're splitting it up with complete proteins, you're going to have at least 3 grams of leucine in every meal. We know that
through chicken, steak,
if
fish,
if you're going to have over 30 or 40 grams, you're going to hit that threshold. Okay. I can't imagine that you can't get. I'm sure 40 grams of chicken will get you there. Whey, you just need less. 25 grams will probably get you there. to get that. But you want 3 grams a meal, spread it out through every one of your meals. That's the trigger.
Okay.
That's minimum.
It's minimum.
That's minimum, yeah.
So is
you can go higher than
that's
that.
the bottom threshold. Is there like a maximum threshold?
That's the trigger. Yeah, that's the trigger. Is there a maximum? Well, I'm sure there is a maximum
Or a
everywhere. Otherwise, you
benefit
just
to
keep
going
building
above?
muscle.
Yeah.
I don't think anybody's ever looked at it. I don't think any more than 5 grams in one shot or 4 grams is going to do much more.
And then let's move on now from hypertrophy and talk about protein and like healthy aging. Okay. So what is the role of protein in aging? What is your goal with protein?
It's exactly the same thing. You want muscle protein synthesis to be greater than breakdown as long as you can. Now, that's never going to happen forever because no one dies at 100 years old looking like Mr. Universe, right? So you're going to go backwards somewhere. And the more experienced an exerciser you are, the less you're going to be able to put on as you get older, of course. However, if you've never worked out in your life, dang, now's the time to start. If you're 50, 60, 70, because you'll be able to put on muscle for the next 15 years. You will, because you just started. And you'll be able to put on muscle protein synthesis as long as you get enough protein. So get your gram per pound of lean body mass and work out resistance training 3 times a week if you can. And that will give you some, for the next 10 or 15 years, be able to exceed muscle protein synthesis would exceed breakdown. But then after that, you're going to come to a plateau and then go the other way. So the goal with protein and aging is to stave off the inevitable loss of lean body mass that happens to everybody and keep yourself from being fucking frail. Because that's what happens. You get frail, you fall, you break, bones break. And again, the lighter you are, the less density your bones are going to have. They don't need to work that hard anymore. So now you fall, you break, and then you're fucked.
Yeah, and we're not.
And the rest of your family's fucked.
And we're not telling you to hold off on working out until you're.
No, we're not doing that. I'm just saying. That's what. But you asked me, what is it in aging?
No.
First thing I would tell somebody.
It was a joke. Because you said 70, if you never worked out before, you can put on muscle.
Yeah, you can.
Because everything's unaccustomed, right?
Yeah,
but,
exactly.
But we're not saying don't work out now.
That's for sure. That's for sure. Yeah, I didn't want to.
Just so you could save your muscle building. For
However, if I hadn't made a living with my body for 20 years, my joints would be a lot more healthy than they are today.
That's true. Yeah, you're a mess. So
I am a mess.
What happens as we age to our muscle? Like, what causes the loss?
Hormones. Remember I talked about the kid, the pre-pubescent?
Yeah.
Right? Those hormones are raging.
Yeah.
And then through puberty, raging. And any guy and even girl will tell you that, up in your 20s, they're raging. Okay, so good things are happening. And then 30s and 40s, they begin to wean a little bit here like this. And this is all of that. And so that's still the muscles you're not utilizing protein as well. Hormones allow you to utilize the shit out of protein. The more testosterone you got, more growth hormone, all these things. The more anabolic hormones you have when you're younger. When you're older, you have less. And now you become what we call anabolic resistant. You're resistant to protein. You can't use it that well because your hormones aren't that high. That's why all these guys are taking hormone therapy these days, right?
Yeah.
And then you've also resistant to exercise. You don't get the same benefit that you used to get because your hormones aren't as high. You don't utilize any of the stuff with your proteins as well. Nothing gets utilized because you're not supposed to be here. Let's face it, we cheated death.
Right.
We're not supposed to be here, so our bodies never figured out how to live longer and be able to, support all that. So the other part now on the muscle side is you start losing motor neurons. And in other words, you had like 50,000 nerves going into your bicep. Now you've got 20,000, right, that fired up. So the muscle fibers just kind of disintegrate because they don't get activated. You got to do a lot more work to activate your muscles too when you get older. That's why we say higher reps for older people. Yeah. You don't want to hurt yourself either, so higher reps is better. But yeah, higher reps for older people, and you can be able to hold. You'll be surprised how much muscle you can hold on. If you can keep resisting training all the way to end of days, you got a great shot. And of course feeding your muscles as well. Taking your subs.
Do you alter the protein intake? As you said, we become sort of like anabolic resistant. Do you start increasing your protein intake as you get older?
If you were going to do that, the answer is yes. But the difference is, like for you, your hormones are still high. So you're using the same amount of protein at 1 gram per pound that I am. I'm just smaller than you now. So that 1 gram a pound works for me just fine, and it works for you just fine too. So it's just easier to stay with that number in people's minds, and no one can really argue that. But yes, the older you are, the more gram per pound of lean body mass you're going to need in protein than a younger person. There's no argument there. But the difference is that there's other things involved with protein besides building muscle.
Yeah.
Satiety, the feeling of fullness, the extra amount of thermogenic effect you get from eating protein. Some of the other nutrients that are in your protein sources. There's a huge value to making sure you do. So it's nothing wrong with having a little extra all the time. But yeah, 1 gram per pound really hits it for pretty much everybody. All right. And a little more for most. A little more for most. Unless you're dieting. Don't forget, if you're calorie restricted, you're going to go higher than that 1 gram per pound.
I mean, this is kind of like deeper down the rabbit hole, but what is the role of protein in cardiovascular health and blood sugar?
Well, in cardiovascular health, I mean, it's just the same thing. It's just that all our tissues are rebuilding without enough protein. It's a secondary source for glucose. And not only that, protein, it's like diabetics, they can have protein. They should stay away from simple carbs because they don't produce insulin well enough to get rid of it, have high blood. So they'll be more on a higher protein diet. So I think from glucose control, it helps with glucose control a little bit, rather than a high carb diet. A higher protein diet will help with all that.
All right, and then
that's cardiovascular health too. People that eat higher protein diets than high fat and high carb, they're healthier cardiovascular wise. It's just because the foods that are attached to it. People that are very overweight, they eat, they get enough protein, trust me, but it's the shit that's attached to the protein that's bad. The fats, the carbs they'll have in the meals and everything else, fattier proteins or fried fishes or whatever. That's the issue there. So leaner proteins play a very big role in maintaining cardiovascular health. Yeah. Mm-hmm. And it also takes the place of shitty foods. And it makes you burn more calories. So that's how it works in cardiovascular health.
What is the role and impact of protein intake on the immune system?
Well, if you don't have enough protein when you're sick, you're going to have some problems. Because don't forget, your immune system relies on proteins to replace all its cells, for all of your immune targets or protein, different proteins, all your things that the immune cells make or certain proteins. So you definitely have to have enough protein. Not to mention, your body is going after the glutamine when you're sick. I kind of explained that earlier on in this session, how important glutamine is to feed your immune system. Your immune system just gobbles up the glutamine, and that's coming right out of your muscles and protein. So you want to make sure you get enough protein, and especially glutamine, because that's that conditionally essential one, along with your, so that 1 gram per pound is still going to be the number that you need there all the way around. But yeah, so yeah, it's support immunity because your body's just crashing. You're losing muscle and all kinds of things are happening during there because your body's actually going to go, it needs to stay alive. It doesn't care how big your muscles are. So it's going to go break down muscle to get the sources of energy that it needs, and it can get it from those amino acids, to feed the immune cells that it needs. So getting enough protein is really important. And it's just hard for people to eat when they're sick.
I mean, we talked about this, right? What is the protein anabolic upper limit? We talked about that, right?
That would be a little bit. That's the muscle full effect is a skeletal muscle. How much can a muscle use? However, the upper limit of the anabolic effect, I'm not sure anybody knows what it is. Remember I said that all your tissues are replacing themselves.
Yeah.
So you can measure whole body kinetics, whole body protein kinetics. That's completely different than fractional synthesis rate of muscle. We can measure how much going on in the muscle, right? We use tracers to find out how much phenylalanine was released or appearance, and then how much was disappeared. And we can tell what's going on in the muscle, the turnover.
Yeah.
Now, whole body kinetics. Well, what's going on in your liver? What's going on your endothelial cells? What's going on in all the cells of your body? We can measure those kinetics as well. So is there really a limit? Probably not. In other words, you can you're going to get enough at the 1 gram per pound, but it's all going to be used. That's why I always crack when people say, well, you can only use 25 grams at a time. You can use way more than that. We already discussed that with the 0.2. But forget, that's muscle. But even your whole body, I mean, it's going to use it all somewhere, even if it's for energy.
Yeah, and that's anabolic, right? When you're building organ tissue.
Organ tissues, that's all anabolic.
We're not just talking about building muscle.
But it's a total anabolism in the body, whole body protein. Yeah. Whole body protein balance. So is there an upper limit? I don't know if anybody's ever discovered one yet. But it doesn't mean that anything better is going to happen. You keep eating more. I think it's just no one's ever written it out.
Yeah.
What it would be. I'm sure we could figure it out.
And I think that does it for everything we got here on protein. I think that covered a lot of it, I sure learned a lot. But do you have a takeaway for us?
Well, maybe we have the same takeaway all the time about the 1 gram per pound of lean body mass. Timing, split it throughout. Most important, right after a workout, and breakfast.
Yeah.
Breakfast, get up and get your 35, 40 grams of protein right there. I know it sounds odd because everybody eats carbs for breakfast, whether it be bagel or this. Hey, just dump some essential amino acids. Break that fast. Okay, fire up your protein building machinery. Get out of that muscle fast. And one thing I really want people to think of, I really want them to go away with this. Think of your whole human structure. Think of your skeletal muscle as this incredible dynamic tissue that is always going through breakdown and synthesis and breakdown nonstop, whether you work out or not, it's going through it. And it replaces itself every 40 days or so. You probably replaced all your muscle tissues, about 1% to 2% done on a daily basis. But so you think about that for a minute. And so why is it like that? It's so it can adapt to your environment. It can adapt to the stresses you put on by when it's breaking down, that can build more. During a regular breakdown, you can suppress the breakdown and you can fire up the muscle protein synthesis, feed it, and it will do that. What happens when you don't get enough? What happens when you're not eating? Well, you don't know. So your body's just going to use that muscle protein and break it down. And it's going, whatever state of your body's in, it's going to supply the amino acids because muscle turnover is very slow compared to like liver and heart. So they replace themselves daily. They're in a constant thing. They don't have to wait for amino acids. They don't have to wait for you to eat something. All your other organs, your intestines, where really dynamic stuff going on, they don't wait for food intake.
Yeah.
They have to replace themselves or you're going to frickin' die.
Yeah.
Okay, so they'll replace themselves the way they're on target with just whatever's left in the body, and it's going to get it from muscle if you're not feeding it enough.
Yeah.
That muscle is an incredible plastic organ that will break down as we need other things in the body and then build as we put pressure on it as long as you're feeding it. And you're feeding it the protein amino acids. So think of it as a dynamic thing that feeds our body when we're not getting enough food. That's what it does. Yeah. We're not getting enough food for everything else, it's going to do that. Unfortunately, it does it every 4 hours, even if you're fat. I don't care how fat you are, you're still going to be catabolic after about 4 hours.
Yeah.
But don't forget, when you're storing fat, that's anabolism.
Yeah.
You're storing glycogen, it's anabolism. You're storing, so at the end of that 4 hours, even if you're 1,000 pounds overweight or 500 pounds, you're catabolic, which is a good thing, and you should be because you need to get some shit out of that fat. But it's also taking the rest of the stuff. So that's to think of it. It's an amazing plastic organ that just moves around based on your body's needs. What we want to do is trick it. We want to trick it to be able to stay and keep building muscle into our old age. And as much as possible, if you're an athlete, repair as fast as possible if you're an athlete. And then to be able to keep building it into old age and stave off the loss of it. And we can do that with the right amount of amino acids coming in, timing, and the right amount. We can do that and the amount of work. And that's about the best way to leave it. Yeah.
And that's the protein episode. And yeah, that should be everything you need to know about it.
That's right.
Moving forward. So you can understand, better understanding for future episodes of whatever we talk about. If you need to come back to this, see what's up, and get all the nitty gritty details. Okay. So we'll see you in the next one. Thank you.
In the meantime, feed your skeletal muscle so you can keep it as long as possible.
All right. And on that note, like and subscribe. We'll see you in the next one. Bye.